Welcome to qnawire.
A quarter circle with rollers on both ends that's sliding down a hill. Point B is moving with 3 feet per second. The partial circle has a radius of 6 inches or half a foot, and we're told that it's rotating with an angular velocity of 2 radians per second. So we want to determine the velocity of point A, but to do that, we need to find the instantaneous center of rotation first. So to do so, we can find the distance between point B and the center of rotation. And we can do that. So the velocity of point B would equal the distance between it and the center of rotation. Center of rotation I'll call C, so this distance BC times omega. In other words, BC equals the velocity of B divided by omega. Velocity of B is 3 feet per second. Omega is 2 radians per second. So this would give us 1.5 feet or 18 inches for our distance BC. Next thing we want to do is calculate the distance between what I'm going to call point D here, which will be the distance between A and C along this triangle right there. So we're going to get distance CD here, which will just be distance BC minus BD. Well, BC is 1.5 feet. BD is just 6 inches, since that's just the radius of the circle. So this would just be 1 foot. Nice and simple for us. Next, we want to calculate the distance between point, sorry, I scrolled that on accident, distance between A and C. So this distance right here, we can use the Pythagorean theorem for that. So AC will equal the square root of AD squared plus DC or CD squared. AD is just 6 inches or half a foot, since that's just the radius of the circle again. DC we found was 1 foot. So this gives us about 13.42 inches, which we can divide by 12 to get the feet. I'm not going to do that at this second. Next thing we can do is find that velocity A. The velocity of A will just be omega times that distance AC, where omega was 2 radians per second. The distance was 13.42. And when we multiply these together and then divide by 12 to get into feet, we get about 2.24 feet per second. If we want to know the angle this is moving at, we can go ahead and take a look at the angle between B and C here. This is the angle theta. Angle between VB and VA at least. We'll know that the cosine of that angle will equal VA over VB. If we solve that for theta, we get that theta equals about 41.8 degrees. If we want to find the angle from the horizontal, sorry, that should be 41.8. I forgot to write the 1. About 41.8 degrees. If we want to find the angle from the horizontal, or the angle from VB in the counterclockwise direction like normal, which I'll highlight in blue here, we just take 360 and subtract that 41.8, and we get 318.2 degrees counterclockwise.